Huskies! This is the last lesson of Unit 4, and we have been solving systems of equations the whole time, but today we're going to solve systems of inequalities. So they're not equal to, they might be less than or greater than or less than or equal to. Those were inequalities. So, to start off with, we have this story about the math club, and they want to advertise in the school newspaper. Usually when you advertise in a paper, you have to pay for it. That's, an advertising budget. And they have $30 to spend. They can't spend more than $30. They have to spend less than $30 or equal to $30. Now, they also want to advertise at least 20 times. Maybe the paper comes out every week or something. Or maybe they just want to make sure they buy at least 20 ads. Maybe there's, 5 pages on the paper and they want an ad on every page. I don't know. But they want to buy at least 20 ads. Okay, both of those things have to be true at the same time. And so let's just try to make sense of this first in our minds. We need to spend less than $30 but advertise at least 20 times. It costs $2 every time you advertise on the front page, and it costs $1 every time you buy an inside page ad. And that's true with real newspapers too. It costs more to advertise on the front page. Okay, so what could make sense? Well, what if we bought 10 front page ads and 10 inside ads? 10 on the front page and 10 on the inside. Each front page ad would cost $2. So that's why there's a $2 here. It's $2 times those 10 front page ads plus $1 for the inside ad times the $10. And so what is that total cost going to be? Well, it's going to be 20 plus 10, which is $30. Hey, neato, they spent all the money. Well, let's see. What's a different situation? Maybe they don't want to buy that many because that was exactly 20, 10 plus 10, that was 20 ads, right? But they want to advertise at least 20 times, so maybe they can get more bang for their buck if they advertise more than 20 times, but don't put so many on the front page. Like, what if they only bought 3 front page ads and 24 on the inside? Well, each of those front page ads is going to cost them $2. So we'll multiply those 3 ads by $2. And each of the inside ads is going to cost them $1, but we're going to buy 24 of those. Well, how much money is that going to cost? 2 times 3 is 6, plus 1 times 24 is 30. So it's going to cost 30, but look at that. They have advertised 27 times instead of 20. So they actually got more ads instead of spending the whole $30 on 20 ads. Well, is there something else they could do? What if they decide they don't want to buy any front page ads? Maybe they want to buy, 25 inside ads. Well, that would be $2 times 0 plus 1 times 25. So that's only going to cost them $25. And they're going to advertise 25 times, but do they have to spend all the money? No, it said they can't spend more than $30, but they could spend up to $30. So they don't have to spend all the money. They could have spent $25, and they could have advertised 25 times. Let's do another one. Let's say they're a little bit lazy. They just want to advertise 1 time on the front page and 1 time on the inside. Well, that's $2 for that front page ad and $1 for the inside ad. That's 2 plus 1, which is $3. What are they going to do with the rest of the money? I don't know. But they don't have to spend all the $30. What was the other restriction, though? They can't be lazy and advertise only 2 times. This would be only 2 ads because it says they want to advertise at least 20 times. So this is not a viable scenario. This is not one that would fit in both of those criteria. These cost $30 or less, but they were also, the sum of each of these was at least 20. Okay, so does it make a little bit more sense in your brain now what's kind of going on? Well, we could do this all day, just coming up with combinations, but let's instead write a rule or maybe an inequality to model this situation. Well, what should our variables be? Look, go back to the question on A. It says, what are some possibilities for the numbers of front page ads and the numbers of inside page ads? Hey, I bet those would make good variables. I don't know how many inside ads or front page ads that we're going to buy, but I could make a variable say that X would be the number of front page ads. How many of those expensive ads are we going to buy? And then Y could be maybe the number of inside ads, the cheaper ones. And some combination of the front page plus the inside is going to give us at least 20 advertisements, but no more than $30. So because we have these two situations happening at once, I think we should write two equations. Let's write, or inequalities, let's write an inequality that just talks about how many ads. How many should we buy? Well, the club wants to advertise at least 20 times. That means that the number of front page plus the number of inside page ads has to be at least 20. It has to be greater than 20, or it could equal 20. It's going to be more than 20, but 20 exactly is also okay. So that's why we use greater than or equal to. Another way of thinking about this symbol right here is saying at least. At least 20 is greater than or equal to 20. Okay? All right, let's write another inequality that talks about how much money are we spending. And this is going to kind of go back to this chart right here. Like, what were we doing in this pattern row? What if we did like 2 times the front page, which was X, that was how many front page ads we bought, plus $1 times how many inside ads we bought? That looks kind of like a good rule to me. And in fact, that is going to be part of our inequality. $2 times however many front page ads plus $1 times however many inside ads. But we only have $30 to spend. We cannot spend more than $30. We could spend exactly $30, but we could also spend less than $30. So that's less than or equal to 30. At most, $30. So this less than or equal to sign is also kind of like saying at most. The most we could spend is $30. We could spend less than that, but we can't spend more than $30. Okay, guys, this is what your system of inequalities looks like. So you're pretty comfortable so far with solving a system of equations. How do we solve a system of inequalities? Well, the answer to that is you have to graph it. Yay! I can hear you cheering. So we have to graph the system of inequalities. I'm going to recopy it right here in case you forget what it looked like. And there's our y, and that had to be less than or equal to 30. Oh, sorry, I mixed up the order. I hope that's not confusing. We had to buy at least 20 ads. Okay, there's our system. Now, let's talk about what would make sense here. Could I buy 2.5 front page ads? No. How would you buy half of an ad? It's not a small one or a big one. You can't buy half of an ad. So you can't have any fractions. Could I buy a negative? No, you can't buy negative numbers of ads. So that's why this is only going to be stuff in the positive range. And it's only going to be whole numbers, if you think about that. So, one problem, though, is that my graph, I had to change the scale so that I could fit it on here. So I'm probably just going to shade instead of just doing dots for all the whole numbers because they're just going to be too close together. Okay, let's graph this. Well, there's a problem. Neither one of these inequalities is in graphable form right now. We like to graph things when they look like this. Y equals mx plus b, where m is the slope and b is your starting point, your initial value, your zero term, your y-intercept. All those things are names that we have studied for b. Okay, let's take this first equation. right here, inequality I mean, and let's fix it so we can graph it. Well, I'm going to subtract 2x from each side of this inequality. You're allowed, I hope you remember from Unit 1, to do the same kind of arithmetic and algebra on an inequality as you do on an equation. So then this would be 1y less than or equal to, what's 30 minus 2x? It's 30 minus 2x. Trick question. Not like terms, can't combine them. But instead of writing 30 minus 2x, I'm going to switch that around just so it'll look more like mx plus b, to say negative 2x plus 30. Okay, hopefully by now you realize that we don't need this 1, because 1 times y is just y, and it looks a little better without it. Hey, that's in graphable form now. My slope is negative 2. My y-intercept is 30. So I'm going to go on my graph to 30 and put a point. That's where it goes through the y-axis right there. Now my slope is negative 2 over 1, and I know my scale is, pretty much every square is 2, but I can still go down 2 of these and over 1, down 2 over 1, down 2 over 1. And this is going to be my line. Oh, I forgot to ask the most important question to start. Is this a dotted or a solid line? Well, it has an equal to bar underneath it. That means I can sit on the fence. I can go right up to, and all the points on the line are solutions to my line. So there is a solid line. And that's what it looks like. That's my first boundary. Now, when we did this on the last homework, we kind of just pretended it was an equal when we graphed that line, and then we tested a point. So we're going to do that right now. Let's randomly choose a point. I am randomly going to choose this point right here. Okay? That point is 20, 10, right? That's the coordinates to this point. So then x must be like 20 and y is 10, just temporarily, so we can just test it. And I'm going to plug in a 20 instead of the x and a 10 instead of the y. Or in other words, I want to put in to this table right here 2 times 20 plus 1 times 10. I've replaced the x with a 20 and the y with a 10. So how much money is this? Well, 2 times 20 is $40 plus 1 times 10, which is $50. Hey, we don't have $50. So that point right there is not a solution, because that would be spending more than $30. So that means that all these points over here, let's make this more fun. All these points over here are solutions. Remember, we can't buy negative, so that's why I'm not going below the line or left of the line. But all the points in this little region right here would work. Oops, I went out of the lines a little bit. They would all work as solutions to be spending less than $30. Okay? All right, let's do the second one. I got to make some room here. So this time, I'm going to bring down my second equation, inequality. Right there. Oh, I got to go back to skinny pen. Okay, so it used to say x plus y is greater than or equal to 20. If we just imagine that instead of the greater than or equal to, that was just an equal. Let's just imagine it's like an equal sign so we can get this in mx plus b form. Well, then we would have to subtract x from both sides. Okay, that leaves me just with a y here. And what is 20 minus x? I don't know, but it's probably 20 minus x. So let's go negative x, or the opposite of x, plus 20 instead of 20 minus x, because that way it's like mx plus b. We like the x term to be first. That means that my y-intercept now is 20, and my slope is what the heck? What is my slope? It's just this thing in front of the x, which is a negative sign. Well, there's an invisible 1 there. And we can turn every slope into a fraction by putting a 1 underneath it. So that means my slope is negative 1 over 1. So I'm going to go to 20 on the y-axis. That is my new y-intercept. Then I'm going to go down 1 over 1. down 1 over 1, down 1 over 1, down 1 over 1 until I get to here. Let's see if I can connect these and make it kind of straight. Sure, like that. Okay, can you see that? So that's my second boundary, and oh, I forgot to mention, yeah, it's a solid line. Because I could buy exactly 20 ads, so it could equal 20. Now we need to test a point. Hey, just for convenience, should we test that same point, 20, 10? Well, if we put in a 20 instead of x, that'd be a 20 right here, and a 10 instead of y, 20 plus 10 is 30. Is that bigger than 20? Yeah, 30 is bigger than 20. This is saying, could they buy 30 ads? Well, yeah, if they had the unlimited money, all the money they want, then they could totally buy 30 ads. So if we're just focusing on this inequality, how many ads should they buy? Well, they should buy at least 20. Okay, then 30 ads works. And so it's actually all these points over here would be solutions to be, hey, can we buy more than 20 ads? All of these points up here would represent buying more than 20 ads. But I know you're thinking, wait, you said we could only spend $30. That's all spending more than $30. You're right. Where is the section on this graph where I am spending less than $30 but also buying more than 20 ads at the same time? Well, it's where the shading will overlap, right in this little region right here. And that, my friends, is the answer to this problem. So the answer when you solve a system of inequalities is where the shading overlaps. So it's just this region over here where we are buying more than 20 ads but still spending less than $30. And because these were both equal to's, then these lines, the boundary lines, are included in the solution. So that is my solution right there. The answer to this system of inequalities is that dark purple wedge right there. Okay, so that's kind of a story problem to help you sort of understand some context about what's going on. Lots of people do this kind of linear programming idea in business. Like in business, you might say, well, I have an advertising budget of so much money, but I really want to advertise this many times. How many, what's the best use of my money? And then you could say, well, any of these situations would work and fit both of those sets of criteria. So that's kind of like an optimization thing that people do in business. This isn't too far away from real life. Okay, on the back, we're just going to practice some basic, this is what you got to do for your homework. This is what you need to know how to do. Before I even start, though, I have to reiterate, you need to know how to graph to do these. You need to know how to graph a straight line for the rest of your mathematical life. And if you still can't figure it out, please come and see me after school. Please go to Math Lab. Please get zapped. Do something. Watch a video on graphing. I have one on my website just on remind you how to graph. You've got to learn this, and you've got to know it forever. Okay, so here's number 2 on your classwork on the back. You have a system of inequalities. It's a system. We are trying to find the place where these two inequalities overlap. Since they're not just lines anymore, we can't just find the point where they cross. We need to find the whole set of all the points where both of them are true at the same time. Okay. Well, step 1 is you're just going to graph one inequality at a time. So you need to graph, shade, graph, shade. Don't graph both the straight lines and then try to shade them because it will be too confusing. Graph, shade, graph, shade. Your answer is where the shading overlaps. So let's graph this first equation, inequality. I know, I'm sorry, I keep calling them equations. But one reason I do keep calling them that is because when we graph them, we're going to just temporarily pretend that's an equal sign. We're just going to temporarily say, well, how do I graph y equals mx plus b? Like this is 3x minus 1, y equals. We're just going to do that. We're going to pretend it's an equal sign. And then when we test a point, we're going to go back to the original and test our point into that original inequality to see where to shade. Okay, y equals, I'm just going to write it down here. 3x minus 1. Negative 1 is my y-intercept, so I go on the y-axis and put a dot. Then, my slope is 3, but we like our slopes to be fractions, so 3 divided by 1 is still 3. That tells me I'm going to, from my point on the y-intercept, I'm going to rise 3, run 1. Rise 3, run 1. You can keep going over and over again to help you get a little better idea of the line. And it's a solid line because it has this equal to bar underneath there. So you're going to draw the solid line. All the points on that line are solutions to this inequality as well. They could be equal. I know, that's a terrible line. Imagine it's perfect and infinitely thin and all of that. Okay, where do we shade? Because you got to graph, shade, graph, shade. So to figure out where to shade, you need to randomly choose any point you want. I'm going to, quote, randomly choose 0, 0, because I like to plug that in. It's easier. Just a little note, you can't choose 0, 0 if your line goes through 0, 0. That will not give you any information. So if your line goes through 0, 0, you have to pick a different point. But this one does not, and so I picked 0, 0. And I'm going to test it into my inequality. So no longer am I pretending this is equal. I am asking myself this question. Is 0, because I plugged in a 0 for y, is it less than or equal to 3 times 0 minus 1? Now, I just want to give you a little warning here. Don't just go with the knee-jerk reaction and be like, yes, or whatever. No, let's think about what we're saying. We're saying, is 0 less than or equal to 0 minus 1, which is negative 1? Is 0 less than negative 1? Would you rather have $0 or negative $1? I'd rather have no money than be in debt. So that means that 0 is bigger. It's not less than, it's greater than. So the answer here, is 0 less than or equal to negative 1? The answer is no, it's not. That means that the point we chose there, 0, 0, is not a solution. It's not cool. Doesn't live in solution land. That means solution land must be on the other side of the fence. Solution land must be over here because 0, 0 did not work. Now, I'm putting the dots because I like you to remember that all those points are solutions to this inequality. But in real life, when I do this, I will just lightly shade in a line in a parallel direction to my line. And I'll show you why in a second, because remember, we're looking for where they overlap. So I will actually just do light shading parallel to my line. Now let's look at the second inequality that we had to graph. It says 3x minus 2y is less than or equal to 12. Well, I got some bad news for you, kids. You can't graph that the way it is. Even if we pretend that that was an equal sign, that's not in slope-intercept form. So you have to actually subtract 3x from both sides. Oh, it's one of those dang literal equations where you just have to get y by itself. You have to do some work first. When you're doing this, it's going to be very, very important that you just pretend it's an equal sign for now and do this algebra with an equal sign. If you leave the inequality in there, you better be really good at solving inequalities and remembering that extra rule that says when you multiply or divide both sides of an inequality by a negative, then you have to reverse the sign. I don't mess with any of that. I just say, well, let's pretend it's equal, figure out where the line goes, and then test a point to see where to shade. To me, that's much easier than trying to remember that rule. Okay, 3x minus 3x is 0. Negative 2y equals y. What the y? What's 12 minus 3x? I don't know. It's 12 minus 3x, but I'm going to switch that around to be negative 3x plus 12. That 12 is a positive because that way it looks more like mx plus b that we're used to. Oh, still not done. We've got to divide both sides by negative 2. Okay, when I divide both of these sides by negative 2, I'm running out of room, I'm going to put it up here, I get y equals negative 3 divided by negative 2. Don't type that on a calculator and get 1.5. That's not going to help you. We like it when our slope is a fraction. Leave it as a fraction. I did negative divided by negative is a positive, but hey, that's what you want right there, a fraction. Rise over run. Now 12 divided by negative 2 is negative 6, and so I'm going to subtract 6. That's our second boundary. Let's graph that. Okay, well, it goes to negative 6. Put a dot. Right there. Then you're going to go up 3 over 2. Yeah, this is why you shade lightly, because you can see it's kind of hard to tell where the heck my stuff goes. Up 3 over 2. Oh, what a mess. Okay, well, we'll do the best we can. Up 3 over 2, it's kind of like this. Yeah, hopefully you've shaded lighter on your paper and you can actually tell where the things go. Now we have to shade. Graph, shade, graph, shade. So we're going to pick a point anywhere. Hey, can I choose 0, 0? Yes, I can. I'm going to choose 0, 0 again. And now that we already know what our rule is, what our boundary line is, we don't need any more of that algebra, so I'm just going to make room. So I'm going to pick 0, 0, and I'm going to plug it into this inequality for x and y, because I want to know if this point right here, 0, 0, if that's in solution land or not for my new line, the brown one I just graphed. So I'm asking myself, is this going to be less than or equal to 12? Well, that's 0, and that's 0. Is 0 minus 0 less than or equal to 12? You betcha. 0 is less than 12. Could have been equal, but it's less than. So that means 0, 0 actually is in solution land. Okay, so I'm going to shade lightly going parallel to my new line. I'm going to shade on the side where 0, 0 lives because that's solution land. Now that I've graph, shade, I'm looking on my graph for where the shading overlaps. Can you see where the shading overlaps? It's in this region right here. This region is my solution set. All the points inside here, this little wedge, are solutions to both inequalities. That's the answer, this shaded wedge right here. And since they were both equal to, then the lines also contain solutions to that system of inequalities. Okay, so what's the answer? Well, it's everything in this wedge right here. But it also asks you to give some possible solutions. You can't name all the solutions, there's an infinite number, but let's name 2 possible solutions. Well, all you have to do is name 2 points that are inside that wedge. So I can tell that one of them is like right here, so maybe 5, 5. That's inside that region. It's true for both of them. Also, the very corner up here would have worked, so I could have said 10, 10. So just give a couple of points in that region that are solutions to both inequalities, and that's how you do it. Whew, that one took a long time. Let's go through these next 2 really quick. Number 3, not in slope-intercept form. I need to subtract 2 from both sides to get it in slope-intercept form. That's going to be y is greater than negative 3. Okay, how do you graph that? I don't see an x. If there's only one variable, it's either a horizontal or vertical line, and since there's a y, it must be like the horizon, so I'm going to draw a horizontal line, right like that. That's y equals negative 3. But it really said y is greater than negative 3. Oh no, it didn't even say or equal to, it just said greater than. So thankfully I can kind of go back here with my stylus and erase stuff. Wow, it won't let me erase very skinny. So this has to actually be a dotted line. This is an electric fence. The solutions do not include the points on the line. You can go right out to the line but not touch it because it's just greater than. Okay, well, name something greater than 3, 4, 5, 11. All of those numbers are greater than 3, and those are the points that are up here. That's where all of your y's are greater than 3. So I just did a little bit of light shading parallel to my original line. Now we're ready to graph the second line. This line is already in slope-intercept form. Cool. So let's just go ahead and graph it. Negative 5, whoops. Negative 5 is my y-intercept, so I'm going to put a point out negative 5. And my slope is 2, so I'm going to rise 2, run 1. Remember, you always want to turn your slopes into a fraction. Rise 2, run 1. It's going to be something like that. And this one is equal to, dun, 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 dun. So this is like you can sit on the fence. So it's going to be a solid line. This line contains all the solutions, not all the solutions. All the points on the line are solutions, but it doesn't contain all the solutions. Okay, so, whoops, that's my boundary. Now, which side do I shade of just that diagonal line that I just drew just now? Because you graph, then shade, then graph, then shade. Well, let's pick 0, 0, because you can always pick 0, 0 unless the line goes through 0, and this one doesn't. So if I choose 0, 0, I want to know, question, is 0 less than or equal to 2 times 0 minus 5? That's just the first step. Let's just plugging in. Let's figure out and really digest this. 2 times 0 is 0. And what's 0 minus 5? That is negative 5. Again, we're asking, is 0 less than or equal to negative 5? Nope, neither one. I'd rather have $0 than be in debt $5, so 0 must be bigger. 0 is not less than, 0 is greater than. So 0, 0, this point right here, does not work as a solution into my rule, into my inequality. Therefore, it must not live in solution land. Oh, sorry. Solution land must be over here. And so again, I'm shading lightly parallel to my line. And by doing that, I can kind of see this region where the shading overlaps. Can you see that some of the shading is going that way, some of it is going that way? And where my region has the shading that overlaps is the answer. So usually what I'll do after I've shaded it lightly parallel to the line and I find where it overlaps is I darken that section in as my answer. All this whole little wedge right here going out forever and ever is where all the solutions lie. So now we're supposed to have some possible solutions. Well, let's see. What are some points in there that would work? How about this one would have been like over 10 up 5. Looks like 10, 10 would have worked again. Wow, I keep doing my volume. Don't know why. There's a lot. Of course there's a lot. There's an infinite number of solutions that would work in there. 5, 0, that's one. 10, 0, that's another obvious one because it's like way over here. Okay, that's how you do it. Number 4. Number 4 is so easy that people trip and fall over it all the time because they forget this simple little idea. If there is only one variable, it's either a horizontal or a vertical line. So this one is like saying x equals 4. X like an axe, like a tomahawk chop. So that means that it's going to be this vertical line right here. And it is a solid line because it's less than or equal to. Well, what's a number less than or equal to 4? How about 3 or 2 or 1 or 0? All these places over here are less than 4. And so the shading on that is going to be all these numbers less than 4. Okay, let's do the second one. Y is greater than 2. Well, if that was an equals and it said y equals 2, that would be the horizontal line that goes through 2. But it's a dotted line because it's just greater than, it's not equal to. So it's a dotted line that goes through 2 horizontally. And it's greater than. So what's a number greater than 2? 3, 4, 5? Oh, okay, all these numbers up here are greater than 2. So where does the shading overlap? Where the shading overlaps is the answer, and it overlaps in this area right here. Go all the way up to the line. Oops, I went over a tiny bit. That is my set of solutions right there. Dun, 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 dun. Well, what are some possible solutions? Some points that are in that region. Looks like maybe 0, 10. That would work. Or negative 5, 5. I mean, you guys pick two different solutions than me. That's kind of fun. Just pick 2 of your favorite points that are in the dark area, write them down. Number 5 is going backwards. And yes, this is still in the classwork, but it's helping you know how to do the homework. So this time I gave you the picture, and you have to write me the system of inequalities. Well, it's going to be a system, so we need 2 different inequalities. Let's start with the blue one, okay? We're going to first write an inequality for this blue one. So we have to know where the boundary is. Can we write an equation for just that dotted line? Well, it goes through 2 on the y-axis, and it looks like your slope is just going up 1 over 1 over and over and over again. Okay, so if that was an equation, it would look like y equals 1x plus 2, because my slope is 1 over 1, which is just 1, and it started at 2. But it's not really equal. In fact, it's got a dotted line, so I know it's either going to be greater than or less than. So I think there's lots of different ways to do this. I don't want to just tell you shortcuts to memorize. Let's go with some skills that you've already learned. You've already learned how to test a point. So let's just guess and check. I know, I actually said you should do that. So let's guess that it maybe is less than. Okay? If it's less than, let's check a point. Like 0, 0, that's right here. We're going to plug in 0, 0 and ask this question. Is 0 less than 0 plus 2? Hey, yeah, 0 is less than 2. That means that this actually is in solution land. It does work, so all these points over here will also work. So that means I guessed correctly. It's y is less than x plus 2. So that's my first inequality that represents the blue. Now let's do one that represents the other line, the solid line. Okay. It goes through negative 1 on the y-axis. So I know it's going to be something x minus 1. I know there's going to be a y. What's the slope of that line? Looks like it went down 2 over 1, down 2 over 1, down 2 over 1. Okay then, if it was down 2 over 1, that is a slope of negative 2 over 1, which is negative 2x. So let's just guess less than again. And now let's test a point. Can we test 0, 0? Yes, we can, because it's not on the line. So I'm going to plug in and I'm going to ask, is 0 less than negative 2 times 0 minus 1? Is 0 less than 0 minus 1? No. 0 is actually bigger than negative 1. So I can't like say, well, then you better shade on the other side of the line. No, what we were testing was, is it less than or greater than? So it looks like I guessed wrong because it's not less than right here. What we just learned is that it should have been greater than. So, okay, fix it. Now you're done. Okay, I'm going to do 3 homework problems. This first one should be pretty simple because they're those nice horizontal and vertical lines. I wish you guys would just kind of like memorize what they do so that when you see them, they're your friend. I love seeing those. Oh, one variable? Perfect. It's either horizontal or vertical. X must be vertical. That's how I think about them. So if this was x equals negative 1, it would have been a solid line through negative 1. But it's not equal to, it's greater than. So that means that I'm going to have a dotted line at negative 1. And my shading needs to be greater than, well, 0 is greater than 1, 2 is greater than 1. That means that it's all of this stuff over here, if I were to shade lightly. Now let's do the second one. If it was equals, it would say y equals negative 3. Y equals is a horizontal line, and it could actually equal this time, so I don't need a solid line. I don't need a dotted line, I need a solid line. So that line represents y equals negative 3, but wait, it wasn't really equal. It was less than or equal. So what's less than negative 3? Oh, like negative 4, negative 5. Oh, all the stuff down here. And so your answer is where that shading overlaps. And that, oh, my bad, with the pink, I should have just shaded all of it, right? Because all those things are less than negative 3. But your answer is where the shading overlaps, which is just this section. And again, you can go right up and include the solid line. that has solutions on it. The dotted line does not. So that's still like a dotted line right there. That's all you have to do. You've solved it by graphing. My answers are right there. All the points in that dark region. Okay, number 6. Let's do it again. Oh man, it's not in y-intercept form. I got to add x to both sides. So that says 4 plus x. Well, that's not very convenient. I wanted to say x plus 4 because I want to start at 4 for my y-intercept and my slope is up 1 over 1 or down and backwards. And it's going to be a dotted line because that didn't have an equal to sign underneath it. So that's pretty much my line. Let's test a point and shade. So if I wanted to test, like 0, 0, because I'm not very creative, and because it's the easiest one to plug in, I'm asking a question. Is 0 bigger than 0 plus 4? No. 0 is not bigger than 4. 0 is less than 4. Oh, poor 0, you're not in solution land. You didn't make that true. Solution land must be over here. Okay. Let's do the second one. It says x plus y is greater than 2, but still not in slope-intercept form. I'm going to subtract x from both sides, and I get that y is greater than, what's 2 minus x? I don't know, but I'm going to write it as the opposite of x plus 2. That tells me to start at 2 for my y-intercept and go down 1 forwards 1, because you're only going to go one negative direction always. And it's also not a solid line because no line underneath there to sit on. It's just dotted. So that's my line, and we need to test a point. So, hey, we can test 0, 0. It's not actually on that line. So then my new question that I'm asking is 0 plus 0 greater than 2? Because now I'm using that inequality. Is 0 plus 0 bigger than 2? No, because that's 0. Is 0 bigger than 2? It's not. 0, 0 is not in solution land. Oh, 0, it lost twice. So that means that it must be on the other side of that line. But where is my answer? What is going on here? It's just this tiny area where the shading overlaps up here at the top. And it doesn't include either of the lines because it was just less than or greater than, not equal to. So that little triangular wedge at the very top of your graph is the set of all the points that are solutions to both inequalities. Okay, last one, number 10. You get to write the system this time. First thing, let's figure out what's the equation of that line. Okay, starts at 2 plus 2. My slope is going up 1 over 1. Okay, so that's up 1 over 1. X, y equals, that would just be the line. Well, looks like it's everything underneath there, so I don't know. Let's test the point 0, 0 and see if it's less than. Like, this is my guess. I think that y is less than x plus 2 would describe that region. So let's plug in 0, 0 to see. I want to know, is 0 less than 0 plus 2? Yeah. 0 is less than 2? Sure. Okay, so that means I originally would have shaded like all of that underneath. But now let's write the equation of this line. It goes through -3, and it also goes up 1 over 1. We know that they're parallel. They look parallel. So this would be y, well, if the other one was less than, I bet this one is going to be greater than x minus 3. Let's test 0, 0 again and see if it works. If I plug in 0, 0 is greater than 0 minus 3. Is that true? Yeah. 0 is bigger than -3. So that means that I would have shaded going all the way up like this. But our answer is where the shading overlaps, and that does make sense because it would have just been shaded in between. So our system of inequalities would consist of that and that. And we could write them with a big curly bracket to show it's a system. Y is less than x plus 2, and y is greater than x minus 3. And that is how you write a system from a picture. I know this was a long video. Good luck. I hope it helps.